gone through how to build your first app. Actually, we went through the basics of Ethereum first, right? With Patty from Arbitrum. We went through how to build your first app, the scaffold UI. What did we do? Over-collateralized lending, prediction markets, stable coins, ZK voting, how to build with AI. Once you've gone through that whole run, once you've done the speed run, you know how to build apps, your next stop is going to be with this man right here at Rare Skills. This is Jeffrey. Rare Skills, I think you said it to me, it's all about math, right? And I think you'll get into it more, but when you're building with us, we're not the math nerds. We're like helping you get the tools and the initial education, but what you need to do is level up and talk to the math nerds next, and that's where DeFi really shines. So I'll just hand it over to Jeffrey, and you take it away. Thank you.
All right, thank you very much. OK, so I'll talk about Rare Skills a little bit more in a second. I'm the founder, just so you have a name to attach to the face. My name's Jeffrey. But let me get a sense here. How many of you have done one? You guys are all developers, right? OK. How many of you have been doing Web3 development for less than a year? OK, how about less than 2 years? OK. All right, that's good. So what I'm going to be talking about is the learning journey for the rest of your time in this ecosystem, because it's a very fast-moving industry. It sometimes can feel very overwhelming, like there's a lot to learn. And I see some people, spinning their wheels when they're trying to make sense out of everything. So I want to provide some guidance around that. But first of all, what's Rare Skills? So we're an education platform that's focused on intermediate and advanced level developers. And something I'm particularly proud of is that we've trained people at the very highest levels. So Cantina is a competitive security platform, and the #1 on the platform was an alumni from us. And we've even VPs of engineering at firms you've heard of have studied with us before. So there's 2 ways that people engage with us. One is we publish content for free. So if you just go to our website, rareskills.io, particularly our blog, you'll see a lot of very detailed walkthroughs on various topics that are pretty fundamental to being a blockchain engineer. Now these are free, so I'm not logged in or anything like that. So you just click read tutorial, and you're off and away, and you can start learning about what's relevant bit by bit. The other thing that we offer, if you just go to our homepage, I'll talk about this a little bit more later, but it's important to actually practice what you're learning. So we give a lot of, these are GitHub repositories with incomplete code or buggy code that you're supposed to exploit, one or the other. OK, so that's the first way that people engage with us. The second way is that for people who want to work with some of our instructors to work through the content, we teach the same thing that's in the content, but on an instructor-led basis. So that's not free, because we need to pay for the instructor time. Only a minority of people do that, but the content's going to be the same regardless. OK, so I'm not going to talk too deeply about our content. I just, first of all, want you to be aware that it exists and that it's pretty widely used, especially if you choose to go into zero-knowledge proofs. Let's see if I can pull that up here. The ZK book, as we call it, this is probably the most used resource in the industry for getting into zero-knowledge proofs. But if you read our articles, we really put a lot of effort into making sure that they're as understandable as possible. So here is a visual illustration of Uniswap v3, and we're trying to say, hey, look, as we change the concentration in liquidity, how is that going to affect how the price is manipulated? So yeah, if you talk to people who know us, you'll know that we put a lot of effort into making things as understandable as possible, because we value your time. Now, so that's where you find it. So the rest of this talk is about how to learn effectively. Obviously, one way is to go to our website and learn, but you don't just learn by reading content, right? So when people get into learning, I think a very helpful framework for thinking about how does learning works is knowing that there's kind of 2 major ways that educators go about it. There's a hierarchical learning and exploration learning. And what exactly is that? Well, first of all, before I educate you on the differences between hierarchical learning and exploration learning, I need to warn you that I'm biased because our school uses hierarchical learning. But I still think you'll get something useful out of this, and I'll say some nice things about exploration learning later. But fundamentally, how do you go about learning? How do you actually know that you've acquired the skills that you care about? Well, you need to produce something, right? Because if you're spending all day just watching videos or reading content, you don't actually know if you learned anything. You want to have something to show for it at the end of the day. And there's 2 ways to go about that. The exploration learning camp says, let's start building projects right away, right? And that's what you guys have been doing in this boot camp. We want to understand how Uniswap works. OK, great. Let's build a copy of Uniswap. We want to understand how oracles work. OK, let's build an oracle. Now, the hierarchical learning approach more talks about, OK, projects are cool, but what are the fundamental skills that are generalizable across everything? And if you really learn those first, then when it comes time for you to tackle your projects, you'll find them a lot easier. At least that's the train of thought behind it. So when people are engaged in exploration learning, it's, hey, I have a project that I'm trying to finish, and by the time I finish it, that's going to teach me everything that I need to know along the way. Hierarchical learning, you can kind of see it in our homepage here, right? It kind of can feel like, I don't know, some forms of tutors, I guess, where you're just doing exercise after exercise after exercise. So you're working with an instructor who has a belief that, oh, you need to follow this particular learning path to get to your destination the fastest. And it will emphasize things like, hey, let's try to make sure we really understand ERC20 tokens. Well, ERC20 tokens, you can ask an AI to create it for you, right? So, and then there's the Open Zeppelin library, which you can just import. So do you really need to know how ERC20 tokens work? Well, the hierarchical school of thought would say, well, because it's so fundamental, you want to have that information be so much second nature that you know it like the back of your hand, so that whenever you're reading code that uses ERC20 tokens, or you are building something that uses ERC20 tokens, you're not spending any mental cycles thinking about how does an ERC20 token work? What functions are available? What's the correct pattern for transferring tokens? Okay, so the hierarchical learning would emphasize you need to spend a lot of time on ERC20 tokens simply because they're fundamental, and you don't want to treat it as an afterthought. Okay, so projects in exploration learning is very much like, hey guys, we're going to learn by building this thing right off of the bat, which is fine. In the hierarchical learning, the emphasis is more on a project should be the sum of everything that you've learned previously. Okay, so we know some tokenomics, we know how ERC20 works, we know how Vault works. I'll get to this in a second. Now let's tie all that all together and then build a project. Okay, so that's where you will see things running a little bit differently. I will say, if you go to YouTube or maybe like Medium or something like that, the exploration learning is what you're going to see most of the time, because it's very interesting to see a project come to life right away. Right, so that's what gets people engaged and oftentimes gets people into the space. So I'm definitely grateful for people who create content like that. I'll just be sharing the school of thought that talks about an alternate way of going about it. Okay, so if I say knowledge gap, does that make you guys at least roughly know what I'm talking about there? Right, you encounter something and you don't really have an idea of what's going on. So in exploration learning, well, this is somewhat easier to handle now that we have AI, right? Hey, I don't know what's going on here. Explain to me the knowledge that I'm missing. But in the hierarchical camp, it would be more along the lines of, hey, we should know in advance what are all the things we need to go into a particular domain, so we should study those first. Let me kind of give you an example. So in our Solidity bootcamp, this is how we teach people to get to DeFi. So the cross-contract calls, how ERC20 works, and binary math foundations. We actually have people memorize all of the syntax here. Right? We actually expect our students to be able to code in ERC20 from scratch. We expect them to be able to make a try-catch call to another contract or a low-level call to another contract from memory. They shouldn't need an AI to do that for them. And but math stuff, there's some basic formulas that get used so frequently that we say, you should just memorize them. And then when the student meets with the instructor, then the instructor actually tests, are they able to produce this knowledge from memory? And not only can they produce it from memory, can they do it fluently? So the idea behind that is that, well, if this stuff comes naturally to you, then this stuff will just feel like a very basic extension of it. So everything you're learning just feels like just one step removed from something that you already know extremely well. So for example, if you know how to bake cookies, then baking a cake is not that hard for you, right? So if you're learning baking, it might be, we would first focus on the fundamental skills, which is, I need to know how to mix flour and eggs together and get the consistency right. Once I have that, then I'll probably bake the least challenging thing to bake, which is probably cookies, and then move on to something that's a little bit more finicky, like a cake. And that's the progression that we see here. So it's not until somewhere around 12 weeks in do people actually start learning this. But the nice thing about it is, by the time they get here, they can read the 3,000-line code base and understand it in about 20 minutes, which I think that's pretty cool. OK, so I just talked about that. Obviously, I'd like it if you guys take our bootcamp, but if you're doing it on your own, this is what I suggest you do. If you really want to commit this stuff to memory because it's going to appear everywhere. You put money into Uniswap, you're going to be dealing with Vault because it's going to give you LP tokens. Same thing if you put it into Aave and whatnot. The inflation attack, well, you can just Google that or ask an AI. But whenever you see a lot of vaults, especially Uniswap, you'll see this strange code in there that seems to be doing something random. And if you spend some time trying to reverse engineer that, that's time that's not going towards understanding the protocol as a whole. So it's good to know in advance, like, oh yeah, this is a very common thing. I should really know that, so when I see it, I understand it in 2 seconds, versus having to spend a few hours learning it. All right? And by memorize, I'm actually serious about that, because that's how if you can recite it from memory, then you've actually internalized it. Because things that are second nature to you are things that you've naturally memorized, right? What's a good example of this, right? You probably, maybe we're in a new country right now, but if you were in your home country, you would know how to walk back to your house if you were put probably within like a 2-kilometer radius away from it, right? Because that's just something that you understand really well. OK, I need to open up VS Code and start a new project. You're not going to Google how to do that. You already know how to do that, right? I'm just going to click this, create a folder, and then run my scaffolding program, right? So obviously the danger here is that depending on your schooling background, you might have had memorization pounded into your head in a bad way. I'll spare you the stereotypes, but you probably know what I'm getting at, right? So yes, you shouldn't memorize some stuff if you don't know what you're doing. Okay, I'm not saying just memorize things if it just feels like a random isolated fact to you. But if you really understand something, you will have it memorized. So a direct path to get to really deep understanding is, hey, these are the things I really want to memorize. All right. OK, so why do we use hierarchical learning? Well, first of all, in our program, we say, hey, we want you to be finished with this program by a certain time, and we want certain outcomes. In exploration learning, you're probably going to have more fun with exploration learning, because you get to try things out, you see results fast, but you probably won't retain the things because you did a lot of things that you didn't understand what you were doing. When we have a time limit, we need to be focused on outcomes, and usually people who are coming to us are willing to sacrifice a little bit of fun to get faster results. So that's, like I talked about, if you study in a way where you're really trying to remember what you learn, and what you're learning directly affects all the stuff that you're going to encounter in the future, it actually doesn't require that much time to learn in this way. In case where does hierarchy come from, right? Because there's a hierarchy to what you learn. I didn't explicitly explain that, but hopefully it's clear. OK, so, but exploratory learning is popular for a reason. You guys did a lot of exploratory learning here. For one thing, I would say if the way you explore a new subject is by drilling the basics in it and by memorizing these core facts, you're going to get bored very fast, right? You have to know, hey, is this actually a worthwhile thing to do or not? And I want to see, hey, what kind of projects am I going to be able to create? So it's totally fine to be building projects for fun. Just be aware that as you're building a project and you're doing a lot of stuff that you don't understand, you're not going to automatically learn it. Just being immersed in a certain place does not mean automatic learning. If you've lived in a country and not picked up the language for like 3 years, you actually see that's common, right? There's a group of, hey, you group of expats, why haven't you picked up the language? You've lived here for a while. Well, just because you're surrounded by something doesn't mean you learn it automatically. It still requires some deliberate engagement on your part, which is why we push for memorization, because it's kind of hard to memorize something without deliberate engagement. OK, but it's a totally valid way to do it. You just want to be aware that these strategies optimize for different things, and that's what you're actually trying to optimize for. OK, so if you were to go off, if your next step, I'm going to sort of presume that if you're in this bootcamp, you're probably interested in, hey, I really want to get into this blockchain space and develop on Ethereum. OK, so here's how I would suggest going about it. I've taught hundreds of people and seen what works, so here's my here's what I would do. This is what we do in our bootcamp, and I'm just telling you this for free. OK, something I say every single week to people who are learning from me is DeFi is finance and finance is math. Right? So at the core of it, a DeFi protocol is just a mathematical model of how someone thinks incentives should work. That's really it. And Solidity is just an expression of that mathematical model. Oh, this text is a bit small down here. Let me make this bold so you can read it a little better. That did not help. OK. Maybe if I do this. A little better. OK. Anyway, the stuff that kind of felt useless in primary school, like logarithms and exponential laws, actually come in handy in DeFi. It's how we pick what size numbers should be. But the good news is you don't really need that much math, but I would say, if you've really forgotten your algebra or you have a non-standard background, then you can learn from Khan Academy for free. In terms of Solidity, Solidity is not that big a language, but the parts that I really recommend focusing on are cross-contract calls. So whenever you see a try-catch-a-call, this is something you really want to understand. Because what makes DeFi different from traditional finance is that it's composable. Hey, I'm going to use your tokens with my router and that guy's lending pool. So you really want to understand the nuances of how contracts talk to each other. Because aside from that, Solidity kind of looks like C or JavaScript, right? So for the most part, it looks pretty familiar. But these parts are the weird parts. They're the important parts. And they're stuff that you really want to make sure that you understand. And if you want to test yourself, just use this free resource over here. OK. By the way, this is in order. So math is something I would prioritize more. And then once you're comfortable with that, like algebra, many of you are probably already comfortable with that. But if not, I definitely recommend brushing it up. Then core Solidity with a particular emphasis on cross-contract calls. Contract inheritance and function overrides are a good thing to practice just because it'll help you understand code bases that you're reading. Like if you look at Aave or Compound, there's like a million levels of inheritance in there. And unless you understand what inheritance is doing, it's a little bit hard to read it. OK, and then the core standards. This is obviously kind of similar to that graph that I showed you earlier, but I'm just putting it out here. ERC20, I actually have people code ERC20s from scratch. It's 9 functions, and after a week of practice, people get it, but it's something that sticks with them for a long time. This is also a helpful resource because not all ERC20 tokens are implemented the same way. When I say a vault, so if you deposit liquidity into a protocol and it gives you an LP token back saying, hey, this represents your share of the pool, then that's a vault. Now, the most famous implementation of it is ERC4626. I don't have people memorize ERC4626 because it's a very big and verbose standard, and a lot of people don't actually use it. But the principle behind it is everywhere. So if you understand how vaults work, then you're just going to automatically understand already 30% of any DeFi code base that you read. Not any, but like 95% of them at least. Kind of unrelated, but this is common too, so it's worth knowing how that works. And then, once you've gotten all that, remember, you want to know vaults, math, and tokens before you start trying to really master the protocols, because the protocols are just the collection of these. In our bootcamp, by the time people get to this point, they understand a protocol in about 45 minutes, because they're just rearranging existing knowledge. But the way that I recommend people really dig into the code bases and really understand how they work is deriving the formulas that are inside of them. That's something that, remember how I said you have to really deliberately engage with something to learn it? For simple concepts like tokens and vaults, you can memorize that. But it would be kind of crazy if you could do Uniswap, even Uniswap v2 from memory. I mean, more power to you if you do that, but I can't do that. So there's definitely a few parts I would forget. But really what you want to memorize is what are the components that make Uniswap operate the way that it does. And if you have those memorized, then you can just figure everything else out as you go. Now, the Uniswap v2 white paper is actually quite good. It shows you all the formulas that are used there. And if you can look at a formula and say, hey, I know where this came from. Or you look at the Uniswap v2 periphery code, which calculates how big a trade needs to happen in order to, hey, I want to put 100 tokens in. How many am I going to get back? That can be mathematically derived from xy equals k, right? It's x plus delta x times y plus delta y is equal to x times y, and then you account for the fee. And then from there, it's algebra. It's worth going through that exercise and making sure that that's fresh in your head, because when you look at that, then you look at the Solidity code, you already understand the Solidity code. Not necessarily because you read the code, but because you already know what it's trying to do. So you're approaching Codebases with a mental model of this is what it's supposed to do versus, oh, I feel like I'm getting knocked around a pinball machine trying to figure out what's going on here. All right, and once you've gotten past that point, you're definitely part of a small group of people. But this is when you can start coding your own protocols. It's a good exercise to start from an empty repo and say, hey, I need to build a lending protocol, or a staking protocol, or a perpetual protocol, or something. And by the time you're at this stage, you already have an idea of, well, I know there has to be a vault. I know that there has to be a way for the users to make trades. I know that we need a way to liquidate someone if they're getting into a risky position. OK, so I'm just going to start coding those one at a time. And if you've already gone through the other 4 suggestions, this will actually not be that difficult. And it will just show you that, hey, because you spent all that time mastering the more foundational things, you just use, it's like Lego pieces, just putting something together to make something more complex. OK, so I've just gone over my suggested study plan for how you kind of get to the point where you're more late intermediate. Because if you're able to code a DeFi protocol from without referring, like especially, these are more simple ones, but I would say if you can make these without referring to a protocol, you're in the very late intermediate stage. So this is a good goal to get to. And if you're focused and you're following the roadmap that I suggested, I think you can get there in 16 to 24 weeks, depending on how much effort you're putting in. OK, but of course, it doesn't stop there. Web3 moves very fast, and it's full of very passionate people, and sometimes it feels very overwhelming. And we've only talked about DeFi here. Maybe you're like, oh, OK, Jeffrey, that's cool, but I'm more interested in bridges or ZK or something like that. And when people look at all of the stuff that there is to learn, oftentimes they get very overwhelmed. Like, OK, cool, I got the basic math down. Now I need to learn cryptography. That's even more advanced. All right, I understood how to make DeFi, but now ZK feels very big and intimidating. One thing that this conversation comes up a lot is when faced with this overwhelm, once every 2 weeks, or maybe even once every week, I hop on a call with someone who's asking for help. Jeffrey, what should I focus on so that I can make money? What industry is going to be hot? Well, first of all, if I knew what industry was going to be hot, I would be a VC, not an educator. And second of all of the hot industries tend to get arbitraged away very fast. So back in 2021, 2022, I could quote people this much money for 100 lines of code or something, just because nobody knew how to do NFTs really. So I was like, whoa, that's a really, really good deal. And this was not me. Some people charged even more. But then, of course, people realized, hey, this is actually not that complicated. Anyone can learn how to do this. So, of course, nobody pays for that anymore. If you're familiar with smart contract auditing, so inside of the smart contract auditing side of the field, there's these platforms where you can participate in. And if you find a bug, you submit it, you get paid money. Maybe about 2 years ago, you could find very simple bugs and get paid a month's salary, sometimes even higher. Nowadays, those issues are so well known that you'll hardly get paid anything for them. So, and even more so, back in 2022, what I would do is hey, you want to get a job? All right, let's build a NFT entirely in assembly, and then let's implement the diamond proxy pattern, which is kind of famously complex. Now, it kind of sucks, but they would do that, and then an employer would look at them and wow, you must be really good at what you do. Let's hire you. So it was a great hack that I could use with some people, and they would get these 6-figure jobs after 6 weeks of effort or something like that, which is great, but obviously that trick doesn't work anymore, right? Because any shortcut to success just tends to disappear. So I would not spend your time looking for shortcuts to success. Instead, what you want to be thinking about is, well, if I'm going to be in this industry, how should I live my life? It's really a lifestyle thing. Don't pressure yourself oh, I need to master all of this stuff soon. All you really need to care about is what are you doing every day? Do you set aside some time to cover up the more fundamental areas that every area of Web3 use? And are you spending some time learning? Now, the nice thing about topics over here is there's a lot of great learning resources. But when you get to more advanced things like advanced strategies for dealing with impermanent loss, then there's suddenly a lot less resource, and if you study it enough, then suddenly you become an expert on the subject. So I would say the way I suggest you live your life is spend some time mastering the fundamentals, and spend some time on, once you've become later intermediate, then spend some time on frontier knowledge, stuff that only 50 people in the world know, stuff that there's no tutorials for, stuff that AI is giving you hallucinations on. If you know that stuff, and you know that well, that's how you get an advantage if you care about career and opportunities. Okay, I was just kind of talking about this, so this summarizes everything I said. Some people, and bless their heart, they read our ZK book and they're like, man, I'm learning some advanced stuff. I'm really excited about this. Well, yes, but the content is available for anyone to read. This is knowledge that not only is known, but our institution has spent a lot of time trying to make it understandable to as many people as possible. What you really want to get to is, I understand something that the AIs don't understand, not as hard as it sounds, and I understand something that very few people in the world understand. That's the strategy that I would think about if I was saying, hey, I want to work in the industry and I want to have an edge. Because I'm going to just skip to this one because it talks about what I was talking about here. Some of you may be looking to work in this industry, some of you may not. So let me just share my experiences as it is right now. If you go to some job board and try to apply as a Solidity engineer, it's pretty rough. Because if you haven't managed TVL, so like a contract that's actually managing money, it's very hard to stand out in terms of your experience. If you try to go the auditing route, well, even right now, there's great auditors who are having a hard time getting a job because it was an easy way to make money, so a lot of people came in, and now it's very competitive. So don't just chase the things that are kind of like in your face, like study Solidity and get a six-figure job, study auditing, get paid a lot of money as an independent contractor. Instead, look for the stuff that doesn't have flashing lights above it if you want to get your foot into the industry. Like I said, niche topics are a great way. Something like bridges and any like ZK off-chain integrations. If you're working and you see opportunities like, man, the tooling here sucks. Foundry is great, but a lot of tooling tends to be a little bit behind, especially if you're coming from JavaScript world. Well, try to build the tool. Right? Try to build a tool that solves it, and you can oftentimes get a grant. It's not as hard as it sounds. Developer relations and solutions engineer roles come up a lot because blockchain is a very social industry. You need to have points of contact, and that's a good way to try to get your foot in the door. And if you are building the actual front end or the back end infrastructure or the DevOps infrastructure, Web3 still needs that, and you can apply any skills you have from the past to get those kind of jobs. Okay, I'm going to jump back to here, and this is just random advice from now on, and then I'll wrap it up on these last 5 points. Okay, like I said, I've worked one-on-one with hundreds of people. The biggest predictor of your success is if you finish what you start. All right, so I've given you a bunch of cool strategies, but kind of none of that matters in comparison to this. And I know it's not novel. There is literally no secret. And it's very hard nowadays because there's a lot of things that are clamoring for your attention. If you go to, when I say crypto Twitter, like, our little bubble on Twitter where we talk about Web3, people are really trying to pull you in each direction to be, get your attention. You're going to have to learn how, and they're really going to try to make you feel FOMO for not working on a certain subject. So you're going to have to resist that and just stick to it. The way I say make it manageable is, you don't have to commit to something for a year in advance. Just say, hey, I'm going to commit to something for 1 week, and I'm not going to get distracted by anything else. Afterwards, like, wow, I actually hated that. I don't want to keep doing this. All right, well, you only lost 1 week, and you learned how to commit to something, so it's still going to be a net positive, and you probably learned something in the process. All right, and along those lines, it's kind of related to what I just talked about. I know deadlines kind of feel like you're bringing school back, but they exist for a reason. They really help you avoid. In fact, if you find, hey, I'm doing something that I don't really enjoy, or I don't really see the point of this, or it wasn't what I thought it was, well, by the time your deadline hits, you have an escape route. So now you're the sort of person who can finish what they start and not stick on something that's actually not working. So self-management, this is actually how I manage the company, just going on a separate tangent. I say, pick you tell me, what are you going to work on for the next X amount of time, and by when are you going to finish it? Because anyone who can do that in a loop is someone who can be a manager of other people. And if they can do that very effectively, then they can be a manager of managers, because they can tell other managers how to do it. Because the whole thing is like, am I working on something that's worthwhile, and am I finishing it in a sensible time frame? That's really it. There's nothing magical to it. So try to apply that to yourself. Okay? I'm also kind of hinting at here that you don't want to just spend your time reading content, right? You want to produce something, right? Because if that's what people are going to pay you for, and it's also a way to really force the information into your brain. Okay, now let's talk about content, because it might sound like I'm knocking content, which would be odd because our company has produced so much of it. Content is obviously helpful. It sucks to learn when there's no documentation, right? But you may come away from, now here's the funny thing. If you, let's say, read about AI, and you read enough clever blogs, you can actually sound like you know what you're talking about at a party. Like, yeah, first of all, we had RNNs, and then we had LLMs, and then we have the bitter lesson. You know about the bitter lesson from reinforcement learning. You can kind of vibe like you know what you're talking about. If you read a lot of content in Web3, you can get to the point where it really sounds like you know what you're talking about. So it may feel like you learned something, and you did to a certain extent, but you didn't get to the point where you could produce something or do something of value. So that's why you really want that to be the goal for the learning that you do. You don't want to just sound smart at the end of it. Okay. Yes. I talked about that already, so I'm going to jump over it. But like I said, think of it as a lifestyle. If I say, hey, you need to get to the point where you understand Uniswap v4, and you need to understand how optimistic rollup works, 7 months, boom, get started. Golly, that would be stressful. I'm not even sure that's possible, right? So, but if I say, hey, but you need to do it over the course of 6 years, you say come on, I do that for 20 minutes a day, I'll get there in 2 years. Right? And 20 minutes a day is nothing, right? So, I mean, it's a good habit. I'm not saying it's an easy thing to do, but we spend 20 minutes a day doing things that are not productive, so we can certainly say, hey, 20 minutes, I'm just going to really lock in and study the subject. So when you look at it on these time horizons, big subjects become a lot less intimidating. People overestimate what they can do. There's a saying, people overestimate what they can do in 1 year and underestimate what they can do in 10. Now, in Web3, obviously, our time travels a lot faster. So I'm going to say people overestimate what they can do in 1 month and underestimate what they can do in 1 year. So just keep that perspective. I mean, I've only been around for 4 years, right? 4 years is not considered senior. But this is a very fast-moving industry where people come and go all the time. So if you can just stick to something, you're automatically going to be in the top 10%. Networking. Yeah. Something else I tell people, hey, Jeff, I want to get a job. Well, the biggest determining factor in that is who you know. Because I've seen a lot of underqualified people get work just because they knew the right person. And I don't mean that in the sense like they were deceiving the other person about their level of skill. It's just, hey, there's this founder guy. He's like, hey, I want to start a Web3 company. I need to hire a blockchain engineer. Well, what am I going to do? Start interviewing a bunch of people on a job board when I don't even know how to interview them? I'm just going to go with my buddy who I trust to not screw me over. So I'm going to hire my buddy. But it turns out Buddy doesn't really understand the domain. He just knows some things about Web3. I see this a lot. So there's a saying that your network is your network. It's cliche, but it's true. Put yourself out there. I've hired maybe half of the people who work for me through Twitter, just because they were posting things like, man, this guy, he likes to tackle hard subjects. That's really cool. I'll send him a DM. And I'm not the only person doing that, because the last person I sent a DM to like that, he said, sorry, Jeffrey, I just got contract work. If you had reached out to me 2 weeks sooner, I would have been happy to do that. Okay, so put your stuff out there, because a lot of other people who are hiring are keeping an eye out for that sort of stuff. All right. OK, let's wrap everything up. I think, yeah, that's the last slide. So wrapping things up, I obviously belong to the hierarchical learning camp. If you're new to a subject, I suggest drilling the basics by memorizing them and making sure that these are things that are generally applicable to the things that you're going to keep using. And then once you have those mastered, you can compose them together into more complex knowledge like DeFi protocols. If you want to learn by building projects and say, hey, I'm going to just figure it out as I go, that's totally valid, and some people have employed that strategy with great success. Just make sure that, hey, this is the way you know that this is the way I'm going about it, I'm going to stick to it, and I'm going to use the exploration learning strategy effectively. Okay, you don't want to just try out a bunch of random different things. You just say, I'm going to do the exploration learning way, or I'm going to do the hierarchical learning way, and I'm going to maximize the benefits of that strategy, and any deficiencies that it has is something that I'm just going to learn to cover for. Do the exercises on the homepage. Obviously, this is coming from a hierarchical guy, right? But I recommend that you work through puzzle. These are free, by the way. They're on GitHub. So you literally just open up one of these things, open the source file, and fill in the missing code so that the test passes. If you keep doing this, then you get very fast feedback about if you understood the subject or not. These things are designed to be finishable in like 4 minutes or less, so you get a lot of nice positive feedback and also learn if you understood the subject or not, because you can't pass the test unless you knew what you were doing. All right, so that's the exercises there. Practice what you read. Obviously, don't just read it. If the article is talking about something mathematical, then translate the code to math. Translate the math to code if it's talking about something mathematical. And then all this wonderful stuff I told you about learning philosophies and strategies for career doesn't matter compared to consistency. That's really the only thing that matters. OK, so if you have any questions, feel free to reach me. I actually make myself available. This week I might be a little slow in getting back, obviously, because this is one heck of a week. I love it. If you want to catch me, we have an event tomorrow where we're doing live smart contract hacking. So you'll get to watch some hackers. They'll share their screen, and they'll be trying to break into contracts. So all the stuff you've learned about security, you get to see in real time. So please stop by there if you feel so inclined tomorrow night. And I think that wraps it up. OK, I'll be over there if you have any questions or anything like that. Oh, yeah, go ahead. Oh, wait, can we get him on my?
Okay, first of all, I wanted to thank you. It was like an amazing talk.
Thank you.
Thank Austin, Patrick Collins, and every guy that is selflessly teaching about all this. Thank you. And what I wanted to ask you, if I had to frontier learning, for instance, account abstraction right now, what path do you suggest, like going through the latest Ethereum improvement proposals, or how, if you have a suggestion for this?
OK, well, account abstraction is not that big a field. There's only a handful of proposals related to them. The point that I would try to get to is where you can code at least the simpler ones from memory, because that means you really understood them. Now, to get to that point, a lot of account abstraction protocols rely on, hey, how do we bundle up a transaction that some EOA is trying to make and then send it internally? So you really need to master how do transactions work, especially when it's working from EOA to contract and from contract to other contracts. And then a lot of the account abstraction things have validation that's not necessarily using the traditional signatures. So that's something in a hierarchical learning perspective you would want to say, well, what alternative validation schemes do these people do these protocols use? And I'm going to really focus on learning those. And learning meaning I can reproduce some information related to how these alternative authentication mechanisms work. So they're made up of authentication mechanisms. They're made up of how contracts interact with each other. Those components are stuff that I would really make sure that I understand in isolation and then bring it together with account abstraction.
Thank you. And one last question. I also watched like on app deciphering about accounts abstraction. There is thing like the entry point, handle users up, and I sort of grasp. But if I want to take it deeper, how can I research beyond what's available? How?
OK, the source of something I tell people, the source of truth is always the source code. You need to be able to read the source code for these account abstraction protocols and understand why they are the way that they are. Right? Not just say, OK, I understand mechanically what it's doing step by step, but why did they make this design choice versus another one? And then you can read through the discussion forums, but generally when you're at frontier knowledge, you can't be relying on AI or tutorials or something like that, right? You need to be able to read, like for example, when we're studying virtual machines, like we write content about virtual machines sometimes, and there's no content on it. What do? Read the source code. Right? Now, you have to put some context in, OK, why is it this way versus another? Well, we can't be sure, but we can certainly see obvious problems that were avoided by doing it this way. So that kind of, being able to navigate that kind of uncertainty is the skill that you need to have frontier knowledge. Now, but to be able to do that, though, you can't, like I said, you can't just be reading code and figuring out as it goes. You need to understand the atomic parts that it's made out of. Like, oh, this is an authentication mechanism. This is a call data bundling mechanism. This was probably an optimization for L2s back when call data was more expensive. So that way, when you're reading the code, you're reading it in chunks, not line by line.
Thank you very much.
Sure. Yeah.
Hello. Thank you for the talk. It was amazing.
Thank you.
My question is, I am not developer, but in my case, I am DevOps SRE engineer. How can I introduce, which will be the path for our mindset or our, background in infra, Kubernetes, and all that stuff?
Is that a field you want to get even deeper into and become like an expert in it?
Yeah.
OK. I'm not an expert on DevOps.
Yeah.
My only experiencing with that is managing DevOps engineers back in my Web 2 days. So I'm just going to try to answer that question from a general perspective of becoming an expert in a field. So there's two components to becoming an expert in a field. One is actually having the skills, and the other one is having your peers recognize you as such. So if you want your peers to recognize you as such, that means you need to produce something that proves that you have the skill, whether it's good content or open source tools that you're creating. Some kind of a verifiable thing like, I'm solving, up until now, unsolved problems. And because those problems went unsolved for a long time, we know that they're not easy problems to solve. And I solved it. So that establishes my expertise. Now, the nice thing is that that goes hand in hand. If you actually solve those problems, you know what you're doing, and you also establish yourself as an expert. So the way that I have seen work with myself and with other people is, if you're, one thing, obviously, you have to be an expert, but how do you be an expert? You need to focus on problems that, as an industry, people have a hard time solving. Right? You don't want to be solving problems that already have a solution, because that makes you a junior or intermediate engineer. Those kind of problems, you need to be able to solve them fluently. Right? You should have no problem solving traditional alerting mechanisms or ingesting logs into storage and things like that, like the very well-known things you need to be good at. But then there's some existing things, like at least to my knowledge with DevOps, there's not so many templates that you can just follow, because every company is different. So what sort of general solutions apply to that in the abstract? Maybe that's not a big problem, and that could just be me not knowing a lot about DevOps, but that's how I would be thinking about it.
Thank you.
Hi, thank you for the talk. So you mentioned about studying every day 20 minutes, and I was wondering how realistic it is when it comes to math, for example. I'm saying it from actual experience. I'm currently trying to do that. And every time I'm starting to, I'm finding myself, oh, fuck, I need to understand this. I need to dive deeper in order to actually practice the things that I learn. And from 20 minutes, it's going to an hour and a half. And I was wondering if you have any tips for that.
Yeah, well, it sounds simple, but it's hard, which is why most people don't do it. So don't beat yourself up if you find it difficult, because everyone finds it difficult. If you find it hard to commit to a course of study, I mean, let's talk about the obvious things. There could be distractions, there could be motivation issues, yada, yada, yada. But let's take that out of the way. If it's still hard to stick to a course of study, then it's most likely because the course of study is above your level or the learning material is not structured well. With math, you want to be more focused on actually solving problems, not worrying about, hey, did I understand this or not? You can apply the algorithms in math to solve things and then understand after the fact why it worked. If you, for example, very bad example, but people use the quadratic equation without knowing how it was derived, right? So it's perfectly reasonable, hey, I want to become fluent in understanding how roots of polynomials work before I understand them in a more abstract sense. But you kind of have to balance that because some people are totally okay with just mechanically doing math, and other people find that like, hey, I at least need to know what I'm doing, so you need to find what works for you. But 80%, at least 80% of your time needs to be spent actually doing problems, whether it's math or some coding thing. And the rest of it is just filling in what you need to know so that you know what to practice next.
A small follow-up. So I feel like in math you have the theory and then you have the practical. So when you say 20 minutes, you're referring to practical 20 minutes, meaning the theory is not in this time that you were mentioning.
For the kind of math that we do, well, what do you want to use the math for?
A variety of stuff, including those kind of stuff.
Okay,
but,
sure.
It's not for here, yeah.
Well, I would say definitely finish like a college algebra or algebra 2 course. That's going to be used in every field in Web3. So just make sure that you've mastered that. Once you're at that point, then it's going to kind of depend on what you're going to do, whether it's going to be cryptography, then that would be more along the lines of number theory and group theory. If it's DeFi, you would probably want to know at least a little bit of calculus, right? So, but honestly, a lot of what we do is algebra, actually. So I would really make sure that you have that down, and it just comes down to practicing algebra problems. So you're using a program that's giving you the problems, right? And you practice them, and you become fluent in it. Oh, over here.
Hi, thank you for the speech. It's very great.
Thank you.
It's good to realize like different ways of learning. My question is about this. I'm a person of I like hierarchical learning as well, but it really takes time. And I'm right now a front-end engineer in Web2, and I'm trying to transfer my career to DeFi section. And I found it's really hard to learn this math and some financial knowledges, especially when we have a limit of time. And plus, we have to learn this alone. It's really painful. Yeah, do you have any tips to relieve this pain, to learn these unfamiliar things? Yeah, maybe find someone to learn together on some community. That's one method I can think of.
Mm-hmm.
Yes.
Well, I mean, the answer I give you is going to kind of depend on your situation. So just feel free to ping me in case I can't give you a thorough answer. But it's going to be painful, right? That's why so few people do it. And the other thing is, you don't need to finish your 20 minutes and feel like it's a success each time. Just having done your 20 minutes and saying I did it, that is the success. And then doing it again and again is the success. And thinking, okay, there's not enough time, I'm busy, but that's why you want to think in terms of 20, 30 minutes over the course of years. There's almost nothing you can't do with that kind of a strategy. You already have a job, so you're in a good place, right? So, that's how I would think about it. If you say, hey, I'm trying to get here in 6 months and I have limited time, I don't know how you could succeed. I don't think it's possible.
So it depends.
Yeah.
Thank you.
Thank you. Okay. I think that's it. All right. Thank you very much.